Hello, this is Lakshmi Kantiwari. In this tutorial, we will learn about the ECG signal smoothing. You know the ECG signal we use for finding the heart rate and the other abnormalities into the heart rate. ECG signal which we read from the electrodes, those ECG signal is a little bit noisy. So before the processing, we need to first denoise the ECG signal, and after that the signal will be ready to process. So let's first generate a artificial ECG signal here with the sampling rate 500, and x is equal to the remat. Okay, ECG with the sampling rate fs. Fine. So the ECG signal, only this ECG command generates a single peak of ECG and it will replaced by the 8 ECG signals. Okay, sorry, repmat, not remat. Okay, so it is repeated here, matrix. Now you can plot it x here. See, this is ECG signal. Now let's fill the ECG signal with the noise. Okay, so x is equal to the x plus normalized random generator number 1 by length of x, and multiply it with let's say 0.18. Okay, so here we will apply a multiple smoothing algorithms, almost 8-9 smoothing algorithm we will learn into this tutorial. So we are going to use here a subplot method where we will see all those 9 signal filtering methods together. Fine. So the very first here, generate a new figure. Okay, and then subplot. So here we are using a 9 row 1 1, so it means the first plot of the 9th row. Okay, then plot x, of course, which I want to plot here. Okay, and don't set other things. Okay, I don't need other, means the axis and the amplitude, all these things. Fine, otherwise it will waste our times. Just give the title here, noise. Fine, SHG. You see here the very first one. Of course it is not very visible here, it is showing very noisy signal. Fine. Now let's filter out this signal is smooth using a Savitsky-Golay filter. So here we want a frame size 15 frame size, and degree is the 0. Okay, y is equal to the S-Golay field, pass the input parameter and the degree and frame. Okay, and here subplot with second row, so 912, and plot y with the title SG filter and SHG. See, this is SG filter data, and above it is noisy data. Finally, of course, you can clearly see the noise has been removed from this noisy ECG signal. Now let's check the another method. a window method. Fine. So let's create here window size equal to the 30 and y is equal to the smooth. Input parameter is x and the next parameter must be the window divided by length of x. Okay, and the next property. So subplot the third row, that is 913, and plot y here and set the title as using a smooth command and SHG. See, this smooth command has been also filtered out this data, but if you compare this SG filter and smooth, the SG filter performs better noise denoising methods as comparison to the smooth method. Now let's check the moving average filtering. So let's place the window size here 15 and create the filter parameter once of the window size 1 and divided by window. So here divided by window. Okay, so it is a moving average filter coefficient. Now we need to calculate y using a filter method. Here h1 and input parameter x. Now let's subplot the fourth row. Fourth row is 914 and plot the y and give the title here moving average filter. And SHG. See, the noise here also has been removed if we use a moving average filters. So here, you know, I think you have got idea how I am implementing here different filtering algorithms which we use for the denoising. Okay, so let's take the another example. Let's take the another method algorithm, that is the moving weighted average window, weighted moving average filter. Let's take the window size here at 7 and h is equal to the Gauss window type. Okay, to multiplied by window plus 1 normalized coefficient window. Now what we need here, we need to set output, we need to pre-allocate the memory of y here. So zeros with size of x. Now implement a for loop here for I equal to 1 to, of course, length of x, and then implement the next for loop j is equal to minus window to plus window. So here the total length is 2 times of window plus 1 including the 0. So minus window to plus window. Okay, now if j is greater than minus I as well as j is less than length of x minus I plus 1. Calculate the yi is equal to the yi plus x of I plus j multiplied by coefficient h. It is just simple filtering. J plus window plus 1, window plus 1, end if, and second for, and end here first for. Now the subplot it, of course it will be the fifth subplot, so the 915, plot it, plot the y, it means, and set the title as a weighted window or weighted MA, you can say weighted moving average filter, and